miss and they join us later, they can join us. So hello and welcome. I'm super excited to be working with you guys. Did you guys get your packages yesterday?
Yeah.
Yeah? Did everybody already open it?
No. No.
Oh, good. Okay. So as you can see, I have two cameras. There's the camera you can see my face, and the camera here where you can actually see what's happening here. So hopefully that'll help out a little bit. If you guys have any questions at all, please raise your hand so that I can see that you have a question. What I will be doing so that everybody can hear is I will be muting everybody when I'm discussing things or explaining things. And then you can unmute yourself. Uh-oh. I gotta put my other and you can unmute yourselves so that you can actually speak. Okay. Does anyone understand? You guys have been here before, right?
Yeah.
Okay. The camera comes back on. Let's see if it pops back in. You see me twice. And it is supposed to be hot today. So I don't know if you guys are warm, but it is warm here in my house. Jacob was cooking breakfast this morning and I'm in the kitchen. So it's super hot in here. I'm gonna go ahead and take off my lab coat. And that way we have air going. Okay, so a couple of things you guys are gonna need. One is you need to make sure that you have a space. You can see that I'm here at my kitchen counter. Here come the bear boys. So I'm working here at my kitchen counter. So
You have to see the
in science, it gets messy. So sometimes you spill things. And if you've got a nice clear space that you can clean it up. A couple of things you're gonna have to pull out of your box. So go ahead and open your boxes. 5 bags in your box. All right, don't pull all the bags out yet. We're gonna pull out 2 bags, okay? We're gonna pull out the bag that has the beads. So find the bag that has the beads. Pull that bag. Go.
No. Hey, why are there campers in here? Found it. My bead box. This one. Oh, found it.
Good.
Oh, this one. Where you let it hang and then it goes down. And then there's also an energy stick where you put this side here.
Other bag that has red test tube holder. And you need to pull the goggle.
I'm fine.
And I won't be wearing goggles. You're gonna pull out the bag out of your box that has the beads. And you're gonna pull out the bag with the red string in it. And in the bag that has the string, you just want your goggles. Now, for those of you who don't have a box, so Chloe and Kayla, you're getting another one today, and Evan and Taylor, or Evan and Tyler, you're also getting another one today. Okay? But typically, when we do any science stuff, we're not going to do anything dangerous. We always want to protect our eyes, and that's why you need those goggles. So you found the goggles, you put the goggles on, and put that bag away.
Oh, there's one in bodies in it.
And
Where?
nice. You should see, and then
Where? I don't see it.
Okay, and those of you who weren't with us in the very beginning, if you have a question, you're gonna raise your hand so I can see you have a question. I have muted everybody, that way everybody can hear. And if you have something to respond with, you're gonna unmute yourself. And you should see two screens. You should see a screen that is with Mrs. Martin and a screen that has my materials. So I'm pulling out materials right now. I want you to open your bags and go ahead and pull out materials. You should have this plastic ring. It's like this. You should also have a bunch of beads. There's a bunch of beads. Mine are kind of mixed up. Okay, you don't have to pull the beads out just yet. You should also have a cup that the beads are in, which is perfect. I'm going to be using this cup because I'm also missing a kit, but I have all these materials, okay? And let's see, you should also have in there a clear plastic bottle. So you can pull out your clear plastic bottle. Awesome. You should also have some balloons. Everyone should have some balloons in there. And you should have some hex nuts. Hex nuts are, I'm going to put it close to this one so you can see. They're little metal nuts. And you should also have a penny. Oops. And there should be a card that's in there with that. All right. So today is Newton's Antics, and I'd like you to unmute yourself and share with me what is something that you may have learned in our virtual distance learning about Newton's laws of motions. Who can go ahead and unmute themselves and tell me what you know? Nobody? Does anybody remember? Well, that's just perfect then. We're gonna go ahead and get started. Okay, so safety first. Make sure if you have your goggles, go ahead and put your goggles on. As I said, today we're not gonna stress too much about wearing the goggles because we're not gonna have anything that's gonna splash in our face. But typically we will put our goggles on first thing when we start. We also wanna make sure that you're gonna keep all items away from littles. I see a few of you have younger siblings. Some of you may also have dogs or cats. I have dogs. My dogs like to eat everything. Does anybody else's dog like to eat stuff? Or their little brother or sister like to put things in their mouth? So we want to make sure that we keep everything together. And when we're done, we want to put stuff back into a bag so that littles or animals don't eat it, okay? And the last thing we need to remember is that as scientists, you have to be responsible, and that means that you have to clean up when we're done, okay? Not mom, not dad. You have to make sure you get everything cleaned up, okay? Does everyone understand? Give me a thumbs up if you're good to go. Nice. All right. Okay, so we're gonna follow the rules. Safety first. Follow the rules. Make sure that you are listening. In your bags, you will find there are some cards. Everything that we are doing is included in that bag, and the directions are in those cards, okay? So if you miss something, please raise your hand and ask, but you can put those cards away and you get to be the teacher later. So if you have somebody who's not with you right now, grandma, grandpa, sister, brother, you get to be the science teacher, and you're gonna take all these materials later and you're gonna wow them with what you've learned, okay? And all the directions are right there, so you'll get to use that. The other thing you need to make sure that you remember is that, as I said, being a scientist means being responsible. So we are going to make sure that we are listening. If we have a question, we are raising our hand. When we are in a Zoom, it's sometimes hard. So we need to make sure we're not drawing on the screen. We need to make sure that we are being respectful on Zoom, and that we are being respectful to those that are in here as well. Okay, thumbs up. Awesome. All right. Okay, so the first experiment we're going to do is called falling hex nuts. Okay, and for this, you are going to need your bottle. So hold up your bottle. And you are going to need one hex nut. One hex nut. You are going to need your card. And that's pretty much it to start with, okay? Now, later, I'm gonna show you guys how you can be even more amazing by using the slow motion camera on your phones, grandmas and grandpas, moms and dads' phones, and they can slow motion this so that you can see just how awesome it is. So what I want you to do, look at that card, okay? And I would like you to raise your hand if you can read that to me. Who can read that to me? Awesome, Mia, can you unmute yourself?
The tendency of an object to stay at rest or to remain in motion until a force acts upon it.
Nice. How many of you are sitting down? Nobody's sitting down? Awesome. Are you at rest or are you in motion when you are sitting down? Everybody shout it out.
Rest.
Rest.
Yes, you are. Yes, everybody's at rest. Okay. So in order for you to be in motion, what do you need to do?
Move around.
Move around. Place your card at rest on top of your bottle. Now your card is at rest. It is not moving, is it? How can you move it? How can you move it? You can unmute yourself. How can you move? I see Chloe doing it. Chloe, what did you do?
I knocked it off of that.
You have to touch it, right? In order to move it, you have to touch it. Now I'd like you to take that hex nut, and I want you to place it directly over. Okay. You don't want to put the edge of the card, you want to put it directly over where the hole of your bottle is. Okay?
Whoa.
Your hex nut, I'm going to put it closer. Your hex nut is sitting on the card, it's sitting on top of the bottle. Okay? Now, you have to get the hex nut in the bottle without touching the hex nut. Okay? So, oh. Try this. Pick up your card and try to dump it in. With that, is the card. Okay? If you slowly, go ahead and set it up again. And this time, first answer me this. Is my nut in motion or at rest right now?
Rest.
Yes, good job. It's at rest. So I'm going to hold the bottom of my bottle, and I want to flick. I'm going to flick the card and fall into the bottle. Okay,
So close.
Into the bottle. Your bottle though, because sometimes you'll not
have a good table. What? Dude, remember we did this with the egg. Yeah, I got it. I just tried it. Yeah,
Evan, tell yourself for the moment. Mia, you can unmute yourself.
Let me try.
Nice.
No.
That isn't working.
Middle finger.
Mine isn't working.
Oh, you got to practice. It does take some practice. So as a scientist, we try again, and it gets better each time we try, okay? Now, the science of this is that if you were able to record this in slow motion, you will see that the hex nut stays at rest, but then eventually it falls into the bottle. Does anybody know why? Unmute yourself. Does anybody know why it falls into the bottle?
the gravity would
The
pull it
gravity.
down, since there's nothing under it to
Gravity
hold
is
it up.
right? The gravity is going to pull it down in. Now here is the next challenge, okay? I want you to try to stack more than one hex nut. So the weight of an object is its mass, okay? So everything has mass. Some has less mass, some has more mass. If I did one hex nut, it doesn't have as much mass as if I have two hex nuts. So now I want you to try to get two hex nuts to drop into the bottle. I got cards flying everywhere over here. You can unmute yourself. I want to hear your discoveries. I think Kayla did it.
I only got one.
Did you do it, Tyler?
I can't. I'm not. I have
Trying to do 4.
If you were able to get two, try three.
Give me one more time. But first, I'm going to do 2.
I can do 2. I need one.
You got the card wet.
Good job, Kayla.
Got both in. Yeah.
Is it easier or harder to get them in? When you increase the mass?
It's easier to get the nuts in when you stack them. I did 3. I
Nice.
didn't do 2, but I did 3.
You're back.
I got 1, 2, and 3. Yay! Now I need to get 4.
And also the Hex Nuts.
Yeah, all 3. Alicia got 1.
Got 3 again.
Actually 2.
Everybody gets one in.
I need to get 4.
Hurry up.
It's hard to stack it.
Hurry up.
To get one of them in.
Well,
We're gonna nurture that. All right, we're gonna make it harder, guys. Uh-oh, I saw someone fall down. Okay, here's what we're gonna do. You need your bottle. Hold up your bottle. Nice, okay? Hold up your ring. Hold up that ring. Okay, you're gonna lay or set your ring on top of your bottle. Whoops, you gotta balance it right on top. Then you're gonna balance a hex nut on top of your ring. And you're gonna try to get that hex nut in the bottle, removing the ring. So see what you can do to knock that ring out. Chloe and Kayla did it. Now there's different methods to this. Well, I see someone flicked it. I see somebody tried to grab it. I've also seen where people take their finger and just put it inside and pull it out. Unmute yourself so we can hear you.
We're trying to flick it again.
Yeah.
There's no way that one's gonna make it. Hey, you have to actually put it here. There's no way. How are you gonna do it?
You
have
guys
to do it. It's just gonna go like this.
Friend, you just have to grab it.
I did it.
It reflected. Hey, that's my ring. We switched. No, this was I like to grab it. Or look. Oh. But all you have to do is grab it. I grab it. Grab it like this. Let me see.
Almost. Let's try and do it with the penny.
Hex Nut.
Working.
Oh,
Hard.
finish.
Saved it.
It's so hard.
To hit it is hard.
Difficult.
Our strongest finger.
Grab it fast. Okay. Whoa. This is so harder than it seems.
Claire's going to do more than one
Ow. Sorry. What the?
Ah, I did two.
Two of them. Nice.
Bouncing off the bottom. So
Great.
Tell me with your fingers, how many were you able to knock in? I see someone's got 2. 0. Oh no. 1. 0. Oh no. Okay, let me show you a technique, okay? There's many different ways to do this, but this is one that may work. So you balance your 1 hex nut. I'm gonna hold the bottom of my bottle so I don't knock it over. Put my finger in the middle of the ring and just pull it out real quick. See if that helps. I'll try it again. Put the hex nut up on top. Make sure you have it right in the middle. Pull that ring out. Ah, I see Brendan and Brian's doing it. Good job. Did it work, Claire? You gotta go real fast.
It worked.
Nice. Now you can try 2. Now that you got 1, you can try 2.
What do you do?
You already got it, so your method was good. Some of them hadn't gotten 1, so we were just trying, if you put 1 on top, put your finger in the middle of the circle, and then jerk it out. Whoops, that time I didn't do it. Uh-oh. No, Claire's doesn't want to stand up. There you, did it go in? Did it go in, Claire?
Just one.
That's so good. Okay, we're gonna go ahead and move on. So if you're doing this later, the bottle sometimes wants to fall over. So what can I do to the bottle so that it won't fall over without holding it? What can I do? Anybody have an idea? How could I increase the mass of my bottle? Unmute yourself, go ahead.
You could attach something to it that's heavy.
But there's something I can do that's even easier than that. Or Brian.
You could hold it.
So you could hold it. Another thing you could do is you could put something inside it to make it heavier. If you have a bottle that's full of water, is that lighter or heavier than an empty one?
Heavier.
Yeah, so you could put water inside, you can put sand inside, dirt inside, something that's gonna add some weight to the bottom. You can even put Play-Doh inside. Just something that's gonna add some weight to the bottom, and that might help some of you who are struggling with getting it to balance. All right, you guys ready to move on? Give me a thumbs up if you're ready to move on. Nice. Okay, so this one, we're gonna switch just a little bit. And hang on just a second. I want to explain what you can do with that trick.
We did experiment 1. We also did experiment 2.
On your camera, let me mute. On your camera, you have a slow-mo application. And so if you set up what you were just doing with your bottle and the ring, and then hit play, and then record that in slow motion, then go back and watch it. And what I would love for you to do is send me the recordings so that I can share them, and you can actually see the hex nut stay for just a split second in the air before the force of gravity takes over and pulls it down into the bottle. So that's a really cool trick for you to do. So we're gonna put the bottle to the side right now, and I want you to pull out a balloon. And then in your bag, you should have had a penny. I want you to shove a penny into that balloon. Now, what we are studying, as we said, we are studying inertia. And inertia, we read that one, it is the tendency of an object to stay at rest or to remain in motion until a force acts upon it. And this was created, or this was discovered long ago by Sir Isaac Newton. When I mean long ago, I mean several hundred years ago. Several hundred years ago. He lived in 1643 to 1727. He was an English mathematician, astronomer. Does anyone know what an astronomer is? Unmute yourself.
Astronaut.
Not an astronaut.
Astronomer is someone that looks at the stars.
Sky. He studies the sky. And a physicist whose theories remain among the most important, like everybody learns about them because they're all around us. Every single, just moving, the act of moving is one of his laws of motion. And so according to Newton, gravity is the reason that everything falls to the ground. So you may have heard the apple fell and hit him on the head, and he invented gravity. He didn't invent, he discovered gravity. The experiments and challenges that we are working on are showing Newton's laws of motion. And there are 3 laws of motion, but the first one is what we've been working on with inertia, okay? The definition you just read. And so in these challenges that we're doing, the hex nut was at rest, and then gravity is that additional force that pulls it down into the bottom. We're gonna do a different activity now where we're working with our balloons. Does everybody have their penny inside their balloon? Okay, now every time I ask people to blow up their balloons, they get a little bit crazy. Now, Tyler and Evan, Kayla and Chloe, there should have been 2 balloons in yours. Do you have 2 balloons?
Yeah.
So if you want, you can go ask mom or dad for another penny, and that way you can both do this challenge. How many balloons were in that package, Kayla? Only 1 balloon was in it?
Actually, we had 5.
Good, super. Okay. So whenever I ask people to blow up their balloon, I always have people get a little crazy and they blow the balloon up super huge and then it's gonna pop. So what I want you to do is I want you to blow the balloon up only about 3/4 of the way. So it's not gonna be the full size of your head, okay? I want you to blow it up and then I want you to tie it off. If you need help getting it tied off, you might ask an adult. Otherwise, if you don't have help and you can't tie it off, you can just pinch it. So I'm gonna go ahead and blow mine.
3/4 of the way. Another one?
Well, 6 inches. Oh, it hurts my cheeks. Just about like this. Not very.
Looks pretty good, doesn't it?
See, it's smaller than my bud, or almost.
Here.
I can't blow mine.
You gotta try. Maybe. Do you have an adult helper who might be able to help you? Blow, 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 blow. You gotta push it in from your cheeks. Grandma or grandpa or sister who can help you with that?
A little bit bigger.
Hold on, guys. My brother is getting some stuff.
Here's a different.
Yeah.
Oh, okay.
Well, I'm having a meeting with my own friends. Well, them are waiting for me, but I'm gonna show you the art we did.
Okay. All right.
This is what art we did.
Don't do that.
Super cool.
It is.
Can you tie it?
Yes. Try it.
You pop it.
Try it. About it.
I don't know.
And this glittery thing is my bow. Bye, guys.
Bye-bye.
There's also another thing. If you hear like a cling in between the penny and any other object, make sure you do not do that and you're like swinging around like this, or it may pop.
That's right.
What is that?
When you have yours blown up, I'd like you to show me that it's blown up so that I know everybody is ready.
I'm not doing anything.
Nice. Okay, we're waiting on 4 more friends. Oh, I can't see Kayla and Chloe.
Mom, I think it's
Nice. So what you're gonna do, those of you you can go ahead and continue with your blowing it up. But you see where I have the little the part where you tied? I'm gonna put that in my palm, and I'm gonna hold the balloon in my palm. Okay. This is another good reason to have a smaller balloon than a really large balloon. Okay. You're gonna try to hold it the best you can here, and then you're gonna kind of bounce it. You kind of bounce it up, and then you're going to start spinning it.
yeah, it's
Circles with your wrist. And when you stop, your penny should still be doing something.
what my brother just did.
What is our penny doing? Does the penny stop, or does the penny keep moving?
Keep moving.
Yes, exactly. Okay. So we have to look at the forces that are being applied to the object. Okay? The penny is my object. In the beginning, if I just hold it, my penny is just sitting here at the bottom. Okay?
No, grab it by this. You have to hold it. Put that in your palm.
It's my penny in motion.
I have to do this.
Is my penny at rest, or is it in motion? Unmute yourself and shout it out.
Rest.
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 So I bounce it to get it moving, and then I start spinning it. And so I'm adding energy, right? I am getting it started with the energy, and I'm going to keep it going, and I'm swirling it. And the shape of the balloon forces the penny or any object to move in a circular path, which is circle, right? Another way to go in a straight line. And there's friction happening here too. There's friction going on between the balloon and the penny. So when I stop, the penny keeps moving, but eventually it stops. Does your penny get slower and slower?
Yeah.
And that's because there's friction that is moving on that as well. It's another force. And the real force action here is called centrifugal force. Centrifugal force. Centrifugal force is a centripetal. I'm even having trouble saying it. This force is always directed towards the center of the circular movement, and it's what's keeping that penny moving in a circle inside the balloon. And out in the solar system, it's the pole of the sun's gravity that keeps the Earth also moving in that centripetal force. Okay, set this aside and get another balloon. And you're gonna need a hex nut. Now, before you drop that hex nut into your balloon, what is the difference between the hex nut and the penny?
The penny's flat.
The penny is flat. You guys can unmute yourself.
The penny doesn't have a hole in it.
The penny doesn't have a hole. What else?
It doesn't have it's not as thick as this one.
The penny is thin and the hex nut is fat.
It doesn't have the corners.
Exactly. The hex nut has corners. How many corners does it have?
6.
Hex means 6. So it's a 6-sided nut. Okay? So the penny is smooth all the way, and this one is not. So we're gonna drop that one in, and you're gonna blow your balloon up. Same way. If your last one was too big, don't blow this one up too big. Well, you guys are just working hard at blowing those up. My cheeks hurt whenever I blow them up. Does anyone else's cheeks hurt? Gotta massage them afterwards. Now, unlike that penny, the edge of the hex nut is not perfectly smooth. It has those 6 edges. And this bumpy ride is gonna cause the balloon to vibrate, which is gonna make something happen. And I want you guys to go ahead and experiment and see what happens. I'm not gonna do it until you've had a chance because I don't wanna blow it up. I don't wanna ruin it for you. So remember, bounce and then spin it in that circular motion. Remember holding it with your palm. Okay, I'm gonna put it on mute so you don't hear. Did anybody hear anything?
It sounds like a beehive.
Okay, so this is a high-pitched noise and it's created by those vibrations as it's running along the latex of the balloon. And as you slow it down, as it slows down, what happens? slows down?
Dad.
Who can tell me? Unmute yourself. What happens as it slows down? Unmute yourself.
The noise quieter.
Ah, so that when I'm going really fast, the vibration is really fast as well, and so I'm getting this like this, and I get a higher pitch. And then as it slows down, that vibration slows down as well, and my sound gets much lower. In your throat, you feel right here, as you are talking, you should feel vibrations. As you talk, you have these two little very special cords in your throat, and they are vibrating as the air is traveling through, and that's how you're making sound. And some make more vibration than others. Now, how many of you have ever taken a balloon that has helium inside, and you've sucked that helium in and then spoke? Has anybody ever done that? So unmute yourself and tell me what happens when you suck in that helium and you speak.
It changes your voice.
It
To
does.
be very high. You start to have a very high voice, basically.
Exactly, because when we have helium in a balloon, it wants to float up, right?
I can't tie it.
It is lighter than air. And so it's causing your vocal cords to vibrate faster. If we weren't in a lockdown situation, I'd be able to show it to you, but it's called sulfa hexachloride. And it's something you should never play with, but it is a cool science experiment. It's a gas that is heavier than oxygen and heavier than the air around us, which has the oxygen. So it causes our vocal cords to move much slower, and you get a really deep Darth Vader-like voice. So it's the opposite of your super high voice. And it's because it's heavier. All right. So that one was cool. We're gonna go ahead and move on. You guys can do these with your,
Can't tie mine.
that's okay, Brian. You can do this later with mom and dad and have them tie it for you, okay? And set this aside, and then you can do that and show them. Yep, now you're gonna need your beads. So you're gonna need a cup, and you're gonna need your beads. And your beads might be tangled up in the bag. So what you have to do is you're gonna have to dump out your beads. I've got some other stuff in here. And then there should be a little red end. And you wanna start loading your beads into your cup and make sure that they're not super tangled. Okay, so you wanna find one end, and then you wanna start loading up your cup, making sure there's no tangles in there. So you might have to lay it on the floor and stretch them all out. If they're tangled, you just have to gently untwist them. Now these are just party beads. So you guys can make this with mom and dad's help. You can make a really, 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 really long chain by connecting them together. Mine might be too much for this cup. I might have to get a different cup. I think I'm going to have to. I'm going to use this instead.
There's like a rubber band stuck in mine.
You might want to either pull it off or cut it off. I think the rubber band was just holding it all together. You might be tempted to just throw it in the cup, And it won't work if we throw it in the cup because it'll be a tangled mess. Kind of like my yarn right now. I have a new puppy and he thinks my yarn is a toy. And so he got into 8 balls of yarn and chewed them all up. And now it's a big tangled mess and I have to undo all of them. All right. So I have one here. I'm going to go ahead and load up.
Oh, man, they're so annoying.
And sometimes the coolest things require a little bit of work.
I'm guessing this is the coolest thing.
Will be one of the coolest things. Now, as my beads are sitting in my cup, are they in motion or are they at rest?
Yes.
Yes, they are at rest. And so I have to be the force that is going to act upon them.
Or does this thing split into 3? Yeah, it's 3. And then there's the end. It all moves together.
Show me.
Now, I have another one that you can see here.
I'm holding on. Oh, dang it. Yeah.
And this one is made
No,
with,
I'm going against me.
have you ever been?
I'm not. I'm not even pulling. I wasn't even pulling. I'm helping pull it fall into the cup.
When you get from the banker pins usually,
Nope, get more out of there.
dog tags, but it's much smaller, but you can do the same thing with these. They're just metal.
Missing what?
Then what you're gonna do,
If they come out in a straight line, you aren't hanging.
camera a little bit, because I might have to hold it over here. All right. It does take some time.
There are 2 ends, and you were on the other end, which made the thing harder. Actually, we're done. We've got it all.
So unfortunately, for the sibling series, only one person can do this at a time, and it takes more effort to put it in the cup than to actually do the same. But if you have to have when they hold your cup up at shoulder height. I'm going to move this up a little bit. So it's at my shoulder height. Okay, so you have the little red beads to the side. You're going to hold the red beads with your other hand, and then you're going to give it just a little tug and let go. And you're going to watch to see what happens. Okay, let's go in here. You do it this way.
What was that?
Happens very fast. And then you got to reload it. So you'll see that the beads are pulling themselves up and out of the cup. And it happens really, really fast. Then you got to put them all back in the cup and do it again. And this is another one of those really cool slow motion videos. And I'm going to see if I can pull, I actually have a slow motion video of this. And I'm going to see if I can pull that up to show you while you guys are reloading. The science behind the fountain of beads flowing from the cup is the science that we've already learned about inertia. And so by lifting the cup high and off the ground, you're providing a source of energy called potential energy. That means that it has the ability to move, but it's not moving yet. So it's potential energy. And the higher you lift the cup up off the ground, the more potential energy that you are creating. So you can even hold it like really high up, or you can even stand up on a chair, which a lot of people do as well. Okay, let me see if I can make this bigger. And I'm going to share my screen so that you can see this little video. You can unmute yourselves. And where's my screen? Move these out of the way. Okay. So here is a slow motion video of, first we have the Hex Nuts. You can see they fall out of it. Here's the ring. This is everything that we've been doing. This is something you can do with mom and dad's permission. You gotta pull the tablecloth from underneath the plates and such.
Come on.
And some of you did this during our distance learning.
I did that one.
Nice, good. So your egg was at rest until you knocked things out. Okay. And here is our beads. So watch what happens to the beads. You'll notice it's coming up out of the cup, and it's going to start gaining energy and come up even higher out of the cup. And as the speed of, well, the initial tug that you do at the very beginning, that's turning that potential energy into kinetic energy. It's the energy of motion. And as the speed of the flowing beads increased, you're going to notice that that chain starts to go even higher, lifting up, and that's because of the fast-moving beads. So if there's a little...
Just pull the red part.
Say it again.
You just pull the red bead.
The red bead's a little tug. Now, Newton stated that an object will continue moving in the same direction, which is initially upward, until an outside force acts upon it. And so what is the outside force that's acting upon this? Exactly. And so the downward force of gravity overcomes the upward motion of those beads. And it happens very quickly. That's why it's always kind of cool to have that slow motion camera.
Then you go to the bathroom.
Go ahead. I'm going to stop sharing my camera or my screen. And that's something that you guys can do, is you can get, with help of mom and dad, use that slow motion camera, and you're going to record yourself as it comes out of the cup. Happens very, very fast. All right, my friends, we have 4 minutes left, and I have one last thing to show you. You do not have this in your bag. This is something that you can do. It's just extra that I thought might be fun. A couple of different things, okay? One, let me set my camera up here closer again. Ooh, I'm all a big knotted mess of chains over here. Let me see if I can get this up down. Okay. So you'll see here that I have some pennies stacked up. You can use pennies, or here are some quarters. Now, are my pennies and quarters in motion or at rest? Are they in motion or at rest?
At rest.
At rest. Okay. I am going to take 1/4 from the top, and I'm going to flick this quarter and knock the bottom quarter out, and that's not like my tower. It's just to take the bottom. So I flick it, and it took out just the bottom quarter. Oh, I don't know if you can see that.
No, don't do that.
Here's my stack. I'm going to flick this quarter, and it takes out the bottom quarter without knocking down the whole stack. So this is another example of inertia. Okay, so you guys can do this. You can also take some cups, and you're going to stack the cups with a card between each cup. Let's see if I can grab it really quick. Cups with a card between each cup. And I'm going to flip. Uh-oh. I need a bigger card. Let's see if I get a bigger card. I'm going to flip that card out without losing your cup. I'm hitting the cup. My card is too small. Use this with an index card. But this is just another example of inertia. And I'm excited for you to experiment on your own at home and see what other examples of inertia can you come up with. There's another one where you can take a hanger, turn it into a W, or I guess it's an M, an upside down W. I'll try to do this one and send it to you, but it's another way for you to then balance 2 tennis balls on your head, and they remain at rest until you cause them to spin, and they will orbit around your head. I'll make a little video of that, and I'll share that with you because we don't have time for me to share it with you now. Did you guys have fun today? You had fun today?
Yeah.
Awesome.
Yeah. Yeah.
What did we learn? What was the big science word today?
Newton's
Inertia.
Motion, good job. Inertia, and what does inertia mean?
At rest.
An object at rest. Of the object to stay at rest or to remain in motion until a force acts upon it.
Exactly. So an object will stay at rest until another force is upon it. Okay? So tomorrow, what you're going to work on tomorrow, please do not open up your bags. I know it's super exciting, and I would want to open all my bags as well. But I keep it going. So you're going to see what you have today, show off all that you learned today. And tomorrow, we're going to be doing Math Science Laboratory. Now, Kayla, Evan, and Tyler, I will be delivering another box to your doorsteps once they are delivered to my house. All right?